In this lesson, we're going to look at solar energy, one of our renewable resources. So there's a couple of different ways that we can use solar energy. Solar energy really is the basis for a number of our other types of renewable energies. There's direct solar energy, which we'll talk about today in this lesson. And then moving water we'll talk about with our hydroelectric power in a little bit. The sun, is responsible for our wind energy, or using our wind turbines, because wind happens because of the uneven heating of the planet, and so it is directly a result of that. And then we'll also talk about our geothermal energy as well. But today in this lesson, we're going to focus on solar energy. There's two different kinds of solar energy that we can use. One is passive and one is active. The big difference between the two, and the picture on the left is passive and the picture on the right is active. The big difference between the two is whether or not there are pumps moving anything around. So passive is just the way that we position a home or a building in order to best utilize the solar energy. So you can see in this one, the roof is kind of broad, so that in the summertime, the sun's rays, when the sun is higher in the sky, the sun's rays don't actually come into the windows, and so it keeps a little bit cooler in the house. But during the winter months, when the sun is lower in the sky and it's cooler out, and we would want to heat our home with our passive solar energy, now the sun's rays are going to be coming into the house more directly. The super windows are usually bigger and thicker, which allows for less heat loss going out into the atmosphere. So this one is obviously, it's more simple when you're building a building. It's very difficult to convert a home to passive solar energy unless your home already happens to be positioned and already has windows going the correct direction. It's a little bit harder to retrofit a home to do passive solar energy. On the right, though, this is what you're seeing all over the place right now, is homes with active solar. And so active solar means that there's pumps, you've got solar panels on the roof. This one is a hot water system, so the water actually gets pumped up through the roof, through the solar panel. As it goes through the solar panel, the sun heats it up, and then it comes back down into a tank where we can hold on to it. So in this one, it's going a little bit further. So now you see this heat exchanger is where it's actually going to then it can be used through a radiator. So now we can actually heat up air and send it out. So you have hot water that you can use as your hot water for your house, but it can also be hot water that heats up air, that heats up the home as well. So here's another look at the passive solar heating. It's also about the way air is moved into and out of the home. You'll see that they also have trap spaces up in the ceiling. So the tube down here in the bottom is the way that cool air will come in to the home. It's called an earth tube, and it'll actually pull air into the home, and then as the sun heats up the air that's inside, it will rise up and go out through the trap. And so you still allow for circulation in the home, as opposed to just getting hot and stagnant and gross in the house. The super insulated window, once again, is going to keep the temperature inside the house more stable. And once again, looking at that difference between summer sun and winter sun, and then using vegetation to help you as well. And that's where that tree is there to help block some of the sun's rays during the summertime, but showing you that during the wintertime, when the leaves fall off, that's why there's no leaves on the bottom of the tree, that when the leaves fall off, now it's going to allow the sun to hit the home. The second picture is showing the addition of a greenhouse on the front. So we call it an Arizona room here in our state, and it heats up the air within that room itself. And so then the cool air goes in there, it heats up, and it comes back into the home. Once again, it can still go up through that trap space. The bottommost picture shows probably one of the more ancient ways of using the earth and the sun in order to heat and cool a home. This one has been in practice for a really long time in the United States. As settlers began to move west, especially in the plain states, they used this a lot, called the earth sheltered home. So they would dig their homes into the side of a hillside, and they call them dugouts then, or sod houses. And they use the earth itself as an insulator. And then you only have the one side of your home that's open to the elements. And so in the wintertime, once again, it you do sort of the same thing like this. So because it's so low, the winter sun will come in, the summer sun will not. But the earth itself acts as a great insulator. So they did this a lot, like I said, across the plain states. They didn't have as many trees to build homes or to burn wood to keep the house warm in the wintertime. So if you had this house where there was only a little bit of it showing, there wasn't as much way for cold air to get into the house, and so your home in the wintertime was easier to heat, and it stayed. So you didn't have to get as much fuel to make it through the wintertime. Because if you're from the Midwest, I'm sure you know how long the winters are. For those of us that have lived out here most of our lives, the winters can be really long there, and they can be very harsh, and so it's a great way to protect. Now here in the deserts and in the hotter regions, it also helps to keep the home cooler in the summertime. And so because it's shaded, as long as you have that ventilation going, it's going to actually keep it cooler as well. So all in all, it's a really good option. So when we look at, we're just going to look at trade-offs. So the sun is free. So obviously the solar panels are not free, but if you're using passive solar heating, and your house is oriented the right way and you can make use of this, it's a really great way of using energy that you don't have to pay for it. You get a lot of energy out of it, and there's no emissions with it, especially if you're just talking about how you orient your house. There's less land disturbance because it's actually your roof or your window that's in there. So when we talk about huge solar farms, that's a different issue. This is right now, we're just looking at using solar on your home. And the passive, once again, isn't very costly. Now, the active is a little bit more costly. There's a lot of tax incentives right now and subsidies that are out there for both homes and businesses, where you can be able to use solar energy. And it can actually feed back into the grid, so you can get paid from the electric company, or it depends on the kind of contract. There's lots of different types out there, but it can be very financially beneficial once you get past the initial startup part of it. You do need a heat storage system. That should be batteries or something like that, or it can feed back into the grid when we're talking about passive solar heating. It does have to be sunny. So, and we think about that like in the summertime, like in June when it's hot and sunny here all the time, that would be our peak time that we make solar energy, and that's not true, unfortunately, because if it's too hot, then the system has to work to cool itself down. So really the optimal temperature is about 85 degrees. So for a good chunk of our year, that's pretty a good thing. So in the wintertime, it's not going to be quite as efficient, but still, it's still going to work. In the summertime, it has to work a little harder to keep itself cool. So when we look at large-scale endeavors for solar energy, there is the huge solar array that's down by Gila Bend. It looks more like this one does out here. So you have just rows and rows and rows of solar panels. They actually have, the energy goes from the solar panels into an area that's filled with salts, and the salts store the energy, and then it can be really slowly over time. So if the system generates more energy than can be converted into electricity right away, it actually will store that energy in the salts, and then it can be released during the evening hours and the nighttime hours, and then that can be converted to solar energy when the system isn't overloaded or not producing, it's not producing excess energy. So you get some good energy out of this. Now, when we talk about it being low efficiency, because once again, it's just like plants, right? So we can't convert all of the energy that comes from the sun. We don't have that capability to be able to do that. So there is energy loss because of that. And there's waste energy, there's the waste heat, just like there is through natural ecosystems. These bigger areas, they do use a lot of land, unfortunately. So they're getting placed in areas that aren't as ecologically sensitive. There's not a lot of people who live around in those areas. And we do need to have some sort of backup system for if it's, for if there's not sunny a lot, but we do put them in the areas that are sunny. So they're fast to construct because all the solar panels could be made off site. They're brought on. It's a very quick, it's a quick operation, but it is costly. So, and we have to look at the trade-off for, what's the energy requirement and the fossil fuel requirement for actually making the solar panels. So that comes into play as well. There's lots of different things to consider. What we have to look at is, do the costs outweigh the benefits, or do the benefits outweigh the costs? And that's where we make our decision about where do we want to use solar energy and where do we want to use a different kind of energy, is where we have to have that the benefits are outweighing our costs. There are some cool technologies out there where they're making solar panels so that they don't even really look like solar panels anymore, that they can actually take the place of the shingles on someone's roof. So this is kind of cool. These are shingles that are solar cells, and they act just like your solar panels do. They're just in shingle form, which is kind of cool. It cuts down a little bit on that ugly factor of the solar panels. The nice thing too is that it doesn't have to be connected to a grid. It can be connected to batteries. A lot of times they'll use marine batteries like you take out of a boat, because they are waterproof and they tend to last a little bit longer. But so we can get electricity to areas where we wouldn't be able to run electrical lines and things like that, because you can take the panels apart and move them individually. You can actually use them in areas like this, in this very. So when we look at our solar cells, they have a lot of the same advantages as our solar panels did. Solar cells being ones that we're looking at just being able to put on rooftops and in solar panels and things like that. Once again, we have a lower land use, lower environmental impact. As we're using them, there's no emissions. You can expand them, they're easy to construct. It's reducing the dependence on fossil fuels to produce energy. But then we have some of the same disadvantages as well. They're not as efficient, and once again, that's because of the amount of energy that comes from the sun that we can't use it all as it's coming in there. They are still pretty costly, and then they use a lot of land use. But so once again, we have to look at what's the benefit versus what's the cost, and we have to decide which is more important, and do the benefits outweigh the costs? And if they do, then we could use solar energy in places, or is it just too costly, and that outweighs the benefits?